Hey, good morning. I am going to try this again. I managed to record the entire lecture and not have my screen projecting onto the recording software, so I'm going to do this entire thing again. This time, hopefully, you will be able to actually see the screen before I upload it to YouTube. I hope you guys are doing well. Hopefully the problems from yesterday, you were able to work through those. Hopefully you saw that I posted a link working through each of those problems. If you do have any other questions on those, please don't hesitate to email me and I will clarify as best I can. So today we're going to continue discussing Chapter 5, Section 2. I'm going to introduce to you a few more log properties. As I suggested yesterday, it is a good idea to have an index card where you're writing these log properties down because there's going to be quite a few of them over the next few lectures, and it's nice to have one place where you can just refer back to the card rather than having to flip through multiple pages and multiple sections in your notes trying to find the different log properties. If we were back in school as normal, if we were in school every day, I would actually allow you guys to use that index card on the test on Chapter 5, but as we all know we're not there. So, okay, let's start with the next four properties of logarithms that we're going to cover today, which is the first one is log base a of 1 equals 0. And what this is essentially saying is it doesn't matter what the base of the log is. If you are logging 1, the answer is going to be 0. All of these are referring back to the very first log property I showed you yesterday, which is when you take it from logarithmic form and put it into exponential form, this should make more sense to you. So the base of the log becomes the base of the exponent, and these two numbers switch, and you can say a to the 0 power is 1 because anything to the 0 power is 1. So that's where this rule comes from. The next rule is log base a of a equals 1. And what that's essentially telling you is anytime the log base is the exact same number as the number that is being logged, then you will get 1. The third property is log base a of a to the x. So what this is saying is if you take log and the base is whatever number and the base of an exponent is also the same number, all of that cancels out and you're simply left with the exponent x. The last property we're going to take a look at is if log base a of x equals log base a of y, then x equals y. This seems complicated, but it's very simple. Obviously, the logs are the same. A is the same as a. We're saying these are equal, and if they're equal, that means x has to equal y. That is called the one-to-one property. So we're going to use each of these to solve a few different problems here. The first problem we're going to try is we're going to try solving log base 4 of 1. And we're doing these without a calculator. We want to refer back to the first property that I showed you on the previous slide, where if you take log of 1, it doesn't matter what the base is. Log of 1 is always 0. Therefore, the first problem is 0. The next problem we're going to try is log base root 7 of root 7. This particular example refers back to the second property that I showed you on the previous slide, where if the log base matches the number that is being logged, then the answer will be 1. So this is 1. The third and final example on this slide is 6 to log base 6 of 20. This one's a little tricky. It does refer to the third property from that previous slide, and it really actually doesn't refer to this first part that I had gone over, but it refers to the second part where, and this is what I really want you to notice, is that if the log base matches the base of the exponent, then all of it cancels and you're only left with the exponent. That also holds true if you have a base and then a power, and the power has a log in it. The base of the power and the base of the log are going to cancel, and you're simply going to be left with x. So going back to the problem that we have for c, you can see the 6, which is the base of the exponent, matches the base of the log. Therefore, all of this is going to cancel, and we're simply equal to 20. All right, these next three examples utilize the fourth rule from the previous two slides ago that I showed you, which is the one-to-one property. The first example is extremely easy. You can see that log and 3, the base, are the same. Log and 3 are the same. Therefore, x and 12, because we're stating that these are equal, x has to equal 12. And that's using the fourth property from the property slides that I showed you. Example 4, part B, is slightly more difficult, not too much. You can see it's log of 2x plus 1 equals log of 3x. You might say, but we're not sure about what the bases are. Don't forget in the previous lecture that I did mention that if there is no base listed, then the base is automatically base 10. So this is log base 10. This is also log base 10. And because the logs and their bases match, we simply set 2x plus 1 equal to 3x. You subtract 2x from both sides, and you get x equals 1. The last problem we're going to try today, and I apologize, I didn't mean for the answers to still be there, is this one. We have log base 4 of x squared minus 6 equals log base 4 of 10. Once again, you can see the log and the base match. Therefore, we can just set the x squared minus 6 equal to 10. You're going to this is a quadratic, but because the quadratic, it has an x squared term and then just a constant, there are no x terms. This one's easily solved by just moving the 6 to the other side and then taking the square root, and you get x equals plus or minus 4. Okay, today's lecture was a little bit shorter than the first day, which I'm sure you guys don't mind. Here are a couple of practice problems that I'd like you guys to try utilizing the 4 new log properties that I introduced today. As always, if you have any questions, feel free to email me. Take care.